stand. Okay, sorry guys, there might be something wrong with... Yeah, I'm very soft. Let's see. Is that better? Can you hear me now? That is better. Okay, I think the stand that my phone was on was probably blocking the mic. Okay guys, so this might be a bit of a wobbly live then because I have to now hold my phone in my hand. Sorry about that. Cool. Alright, let's get started guys. So, if you are in matric this year, which I'm guessing you guys are, your first topic is going to be sequences and series. Now guys, some schools might do topics in a different order. Okay, so at my school, the school that I teach, we also always start with number patterns, and according to the departmental guidelines, that is the first topic, but you might start with a different topic. But yeah, anyway, then you will be ready for this. Okay, so number patterns that you did in grade 11. And I must apologize, I'm a bit out of practice with writing. I don't know if it's the same with you guys. At the beginning of a new school year, I always feel like I've forgotten how to write. Okay, so number patterns. In grade 11, you did two types of number patterns. The first type was linear patterns. Alright, the first type was linear patterns. And what a linear pattern is a pattern with a constant first difference. So, for example, if you have something like 7, 13, 19, if that is your number pattern, right, and you are now asked to find the general term. We'll get to that formula just now, but this is an example of a linear pattern, because if you look from 7 to 13, so from term 1 to term 2, you are adding 6. From 13 to 19, you are also adding 6. Am I speaking? Yes, I am. Some people said you can hear me. Kiara, are you struggling to hear me? Just let me know if you guys can't hear me. Okay, now, as we can see that from term 1 to term 2, we're adding 6, and then again from term 2 to term 3, we're adding 6 again. Thank you for letting me know. Alright, you're adding 6 again. So the fact that we're adding the same number consecutively, that means that we have a constant first difference. Alright, so that means that we have a constant first difference, and that value is D. Alright, the constant first difference is 6. D is equal to 6. Now, in grade 11, some of you might have learned this formula, which is also the formula that you will find in my note, the note that is on my Google Classroom. So, term N is Dn plus C. You might use different letters. Yeah, sure, Kiara, I'm not sure how to help. Maybe go off and come back on again. Okay, so this is the formula that's in my note, where D, you can see, is the first difference, the constant difference, all right? And then C, you'll have to find by inspection. So, for example, if we're saying, yes, you can use A instead of D, that's perfectly fine. All right, I'm actually going to show you guys a new formula today, which is the formula that you are supposed to learn in grade 12. All right, which is the formula that you're supposed to learn in grade 12. Okay, so this is like the grade 11 formula. We're going to go through the grade 12 formula as well. You can definitely use A instead of D. All right, so then your first difference would be A. All right, I'm just using D. So here we would say that our formula is 6n plus C. Now we need to figure out what C is. Right? So now in order to figure that out, we're going to say, remember that n is always the term number. So if your term, this one here, 7, is your first term, that's term 1. That means that n in this case would be 1. Now if you take 6 times 1, so 6 times your term number for the first term, the term number is 1. If you take 6 times 1, that's 6. And then what must you add to 6? Right? To get to 7? You would have to add 1, right? Because 6 times, or 6 plus 1 is 7. So that means that C is going to equal 1. And you find that by inspection. So that means that your formula is in fact 6n plus 1. All right, so the D, or whichever letter you were taught, it doesn't matter. You can use a D. Many of you used A. Whatever that letter is, the letter that's the coefficient of n, right? The number that goes in front of n, that is your constant first difference. And then the C value, I think some of you might have used B for this instead of C, but that's also fine, is then a plus 1. All right, so that is the grade 11 way of doing it. Now in grade 12, we teach you a new formula. And it is a bit silly for me. I don't quite understand why they want you to do one formula in grade 11 and then a different formula in grade 12. So I often actually teach my grade 11s the grade 12 formula right from the start. So this is the formula that is going to appear on your formula sheet. Right? Some of you might have seen it already. Some of you might not. Okay, but this is the formula that you are going to use in grade 12 for a linear pattern. Another thing is, in grade 12, we don't call them linear patterns anymore. We actually call them arithmetic progressions or arithmetic sequences. All right, so that is the new name. We use AP as an abbreviation for that, and AP stands for arithmetic progressions, or progression, or the other word for progression is a sequence. Okay, a number pattern, number sequence, it's the same thing. So in grade 12, you are not going to be talking about linear patterns anymore. You're going to be talking about arithmetic progressions. Yes, okay, I see Lani Chalke is saying you used this one last year in grade 11. Perfect. Okay, some people didn't learn this in grade 11, but you all are going to learn this in grade 12. Now, the difference between these two formulas is that we are using different letters, and you can also see that in this formula we have a D and a C, or an A and a B, it depends. Here we have A, which actually, if you used A here, this A represents something different. D again is your difference. Okay, so for this formula, I'm going to write down what each of these variables actually represent. Let me just grab a different pen. Oh, sorry. It's a bit awkward because I have to hold my phone in my hand now. All right, so A in this formula is actually the first term. Right, so A is always your first term. N is the term number, and D is your first difference, the constant difference, the number that you are adding to each term in order to get to the next term. All right, so what I'm going to do quickly is we're going to look at this same number pattern and we're going to apply this formula and see if we can get the same answer, if we can get the 6n plus 1. So again, if we have our 7, 13, 19, and then obviously the number pattern would continue like that. You are going to first look at what are you adding. To get from 7 to 13, you're adding 6. And then to get from 13 to 19, you're adding 6 again. So you have a constant first difference. So it is an arithmetic progression. It is an AP, a linear pattern. Alright, so now if they're asking you to find the general term or the general formula of this number pattern, you're going to write down the new formula. A plus n minus 1 times d. Then we are going to now substitute all of the values in that we found. Okay, now in this new thing, remember A is the first term. So the first term is 7. So that is what we're going to use for A. So we're going to have A plus, so the first term plus, so 7 plus. Now, since we're finding the general term, Tn stands for the general term, the specific term. All right, so if there was a 1 there, this would be term 1. So yes, n stands for the term number, but Tn is that specific term. Okay, you're going to work a lot with this formula, and I'm going to make loads of videos of different ways in which you can apply this formula. So don't stress about that too much for now. Tn is like the general term. All right, so it's like you're finding the formula for this number pattern. Okay, so we have 7 plus. They're not asking us for a specific term, so we don't know what n is. We don't know what the term number is. All right, so we're going to leave it as n. And then d is now the constant difference, the number that we're adding each time. So a 6. Now guys, this is a bit of a strange way of writing it, right? Because in algebra normally, we would put that d in front of the brackets. Okay, what that means is this whole bracket, this n minus 1, we are multiplying by d. We're multiplying by whatever the constant difference is. So that's 6. It actually would have been more understandable if the 6 was written in front of the brackets, right? That's normally the way that we write things down in algebra. So we would say 6 times n minus 1. In this case, we've just said n minus 1 times 6. Okay, it means the same thing. We're still going to have to multiply the 6 by the n and then by the negative 1. So we're going to say this is 7 plus, and then n times 6 is 6n, and negative 1 times 6 is negative 6. All right, and now we notice that we have two what are they called again? Sure, I'm rusty. Like terms. There we go. We have two like terms here. What is 7 minus 6? Right, we have our 6n. That's the only term with an n. And then we have 7 minus 6, which is positive 1. Notice that we are finding the same general term, the same formula, the same nth term, the same formula for this number pattern, whether we use the grade 11 form of this formula or the grade 12 form of the formula. Okay, so that is the formula that you guys are going to use in grade 12. I just want to show you quickly how to use this formula to answer different types of questions, because remember, they don't always just ask you to find the general term. They can ask you different things as well. So I'm going to write down an example here. Just move this up. Okay, this is now a brand new example where we're going to go from the start and we're going to answer multiple questions on the same number pattern. Okay, sorry that those lines are a bit skew. I can't use a ruler now because I only am working with one hand. Okay, so we are working with the number pattern 17, 13, 9, 5. Notice that we're going from bigger numbers and the numbers are getting smaller. We are actually subtracting values here from each term. Alright, so for the first question, they're asking if the pattern continues in the same way, write down the next 3 terms. Okay, now in order to get the next 3 terms, we actually first need to figure out what's going on here. We need to see how are we getting from one term to the next. Because if we can figure that out, then we have to do that in order to get the next 3. All right, so from 17 to 13, all right, I think you will be able to notice that we are minusing 4. Right? And then from 13 to 9, you also have to minus 4. 13 minus 4 is equal to 9. And then 9 minus 4 will also give you 5. All right. Yes, I see the correct answer already. So now in order to get the next 3 terms, we have to continue that pattern. They're saying if the pattern continues in the same way. So we need to keep doing that. So now for the next term, we're going to have to say 5 minus 4. And 5 minus 4 is 1. Then to get the next term, we need to say 1 minus 4, which is negative 3. To get the next term, we need to now say negative 3 minus 4, which is negative 7. Okay, so those will be the next 3 terms. Well done. Number 2. They are now saying here, write down a formula for the nth term. Oh, sorry. Sure, it's a bit hectic having to try and keep the phone straight the whole time. Sorry about this. Okay, write down a formula for the nth term. Now, guys, the nth term, there are different names for that. They can ask the same question using different words. So instead of using the words nth term, they can just say Tn. All right, term n. They can say general term. All right, that's the same thing as the nth term. They can also say general formula. So they could just say write down a general formula for the sequence. All right, so instead of nth term, they could have just said general formula. What is important is that when you are writing down a formula for the nth term, there is going to be an n in that formula, right? That is important. So for the nth term, you have to have an n in the formula. Like we did up here, when we found term n here, there was an n. When we found term n here, there was an n. All right, so if they're asking for the nth term, you have to have an n in that formula. All right, so let's get going. Write down a formula for the nth term. What I always do is I first just write down that formula, the new one that I just showed you guys now. So a plus n minus 1 times d. All right, I see there's already an answer. We're going to see if that is the answer just now. Okay, so we look at, remember a is now your first term. So in this case, for this number pattern, the first term is 17. All right, that was the first term. So a is 17 plus, remember what I said, when you're finding the nth term, you need to have an n in that formula. So we're not going to put in a value for that n. We're going to leave it as n. So n minus 1 and then times d. Now, guys, in this case, the constant difference, we're minusing 4 every time. So the constant difference is negative 4. All right, so that is what our d value is. Okay, we got some answers. Let's see. Now this 17, I'm just going to leave it as it is for now. But now this negative 4, we need to multiply into the bracket. Okay, so we have negative 4 times n. That is negative 4n. And then we have negative 4 times negative 1, which is plus 4. Alright, and now final step, we need to simplify that because we have like terms. 17 plus 4 is 21. So you can write it like that, as 21 minus 4n, or if you want, you can write it as negative 4n plus 21. Okay, it's the same thing there. You can write it in either way. Alright, so just check if you got an incorrect answer there. Just make sure what you did wrong. Okay, you need to put in your a value, then your constant difference value, multiply the constant difference into the bracket, and then simplify, and then there you get your general term. Now guys, what that means is that this is actually a formula that will give you the value of any term in this number pattern. Alright, so if they are saying that these are the first 4 terms in this number pattern, now you need to find the 300th term in this number pattern. You are not going to sit there and minus 4 300 times in order to get to the answer. You can now actually use this formula, and where you have an n, if you're needing to find the 300th term, you're just going to put 300 in the place of n. That will then give you the value of the 300th term. Right, so this formula is actually very useful because, like I said, using this formula, you can find any term in this number pattern without actually having to do the manual minusing of 4 every single time. Okay, so this is a general formula, also called the general term or the nth term, or Tn written in that way, of this number pattern. And we need to remember that because we're going to use that. Okay, so that was question 2. Question 3, I'm going to squeeze in here on the side because I'm going to have to turn the page just now. So question 3 is determine the the 163rd term. That is question 3. Now guys, like I just said, we're not going to now manually sit and minus 4s over 100 times until we get to term 163. We are going to use our general formula. So we're going to write it like this. Term 163, so the 163 is a subscript like that, is equal to, remember that this was our general formula. So we're going to use this general formula now. We're going to say negative 4 times, and instead of n, now our n value, our term number, is 163 plus 21. Alright, so we're using this general formula. The only thing that we're changing is we are now putting the term number that they gave us, 163, in the place of n, and then we're going to work it out. Alright, and in this case, that was, yes, someone said, yes, good guys, negative 631. That is the 163rd term of this number pattern. Okay, let me know if you guys have questions along the way and I'll answer them. Alright, but I think you guys will probably be fine up until this point. Alright, going to a new page. Okay, so that was question 3. Now, question 4. Let me just get to the page. Is now asking which term in this number pattern, obviously, has a value of negative 255. Okay, which term, in other words, which term number will be negative 255? Basically, they are asking us for n. What must n be? Term what? Term n? Term what will be negative 255? So what we're going to do is we are going to say that term n is equal to negative 255. right? The general term is negative 255, and we now need to figure out what that term number is, what that n is. All right, we have an answer here. We'll see now if that is the correct answer. All right, so now what we're going to do is we're going to use our formula for term n. Remember that term n was negative 4n plus 21. Do we remember that from the previous page? So now we're saying that term n is negative 255. So we're going to take that formula that we found and make it equal to negative 255. So we're going to say negative 4n plus 21 is equal to negative 255. And now this is just a normal, equation that we're going to solve now. All right, so this plus 21, in order to get rid of it, I need to minus 21. So I'm going to minus 21 on that side as well. So I'm going to get negative 4n is equal to negative 276. All right, if you want to, you can just cancel out the negatives, or you can just say that you're going to divide this number by negative 4. You'll get the same answer either way. So you have negative 276 divided by negative 4. So n is equal to, like many of you guys said, 69. All right, so that is saying that term 69, the 69th term, is negative 255. All right, these are all very common grade 11 questions, but also very common grade 12 questions. All right, you will get asked questions like this in grade 12 as well, using the formula that I just showed you guys. All right, there will be more complicated questions that they'll ask you in grade 12, but I don't want to get into that now. I just want to make sure that we are all on track with the grade 11 content. Okay, let me know if you guys have any questions. We're going to move on to quadratic patterns now, because that was the other thing that you learned about in grade 11. So far what we've covered is we went over linear patterns, and we discussed that linear patterns in grade 12 are now known as arithmetic progressions or arithmetic sequences. And then we learned a new formula. So instead of Tn is an plus b, or dn plus c, or any kind of variation of that formula, we learned Tn is equal to a plus n minus 1 times d. All right, so that is the new formula that we learned, and we've practiced it now. Okay. Quadratic patterns, that is the next thing that you learned about in grade 11. Now, I have good news. In grade 12, this is not changing at all. They are still called quadratic patterns, and you are still going to use the same formula that you did in grade 11. All right, so that does not change. You are going to learn about a different type of pattern, which we won't cover today. All right, we'll cover that later on. But yes, quadratic patterns will stay the same. Now, a quadratic pattern is where you have a constant second difference. And there are two methods that you can use. You can either use the T0 method, or you can use the formula method. I don't really like the T0 method. In my experience, people just get quite confused with how to use that one. So I'm going to go over the formula method. But if you prefer the other method, that's perfectly fine. You can definitely use it. You'll get full marks if you apply it correctly. And there is an example in my note on my Google Drive, if you want to go look at that, if you want to see the T0 method. So I'm going to use the formula method. And in the formula method, let me just write down here quickly. The general term for a quadratic pattern is an squared plus bn plus c. Now, when I say that we have a constant second difference, it's something like this. So if we have like 6, 13, 26, 45, for example, say that is our number pattern, right? Now, if we look at these numbers, we see that they're getting much bigger very quickly. So, for example, if we go from 6 to 13, we're adding 7. But 13 plus 7 would give us 20, not 26, right? So actually the first difference here from term 1 to term 2 was 7, but from term 2 to term 3 is not 7 now. From 13 to 26, you're actually adding 13. So hopefully you guys can notice that we don't have the same number that we're adding. So we don't have a constant first difference here. Now, from 26 to 45, we are actually adding 19. So again, that is a different number than the previous one. So we do not have a constant first difference. Now, if that happens, guys, you need to look at your second difference. So now we're going to see, okay, from 7 to 13, I'm adding 6. So this is now my second difference. Then from 13 to 19, so again, I'm looking at the first differences and I'm seeing basically the difference between those. So from 13 to 19, again, I'm adding 6. Now we notice, these numbers are the same. I have a constant second difference. All right, so that is quite important. So now, okay, sorry about that, guys. Just let's see, are we back online? Yes, okay. I just had to switch the Wi-Fi off. My apologies. All right, so what I was saying is our general formula for a quadratic pattern is Tn is an squared plus bn plus c. You are first going to find your a value. Now, the formula that we use for that is that 2a is equal to your second difference. Or if you want to look at it slightly differently, you can say that a is equal to your second difference divided by 2. Alright, so in this case, our second difference is 6, meaning that a is going to be 6 divided by 2, so a is going to be 3 in this case. Alright, so that is how you find the a value of a quadratic pattern. Then, next up we're going to find b. And this is the second part of the formula that you need to remember. So the formula is that 3a plus b is equal to your first difference. Now that sounds a bit strange. I'm just going to write it down. So your first difference. I'm going to write it down in a slightly different way just now. But if we're looking at this number pattern here, remember this is the example that we're looking at. Here we have our first differences, right? And remember that they are not constant because we have a quadratic pattern. So 7, 13, and 19. The first one of those first differences was 7. Okay, so this plus 7 is our first difference. Yes, the first term of the first difference. So if you want to write this slightly differently, you can also say that it is term 2 minus term 1. All right, that will always give you 3a plus b. 3 times your a value plus your b value is equal to your first difference. Now guys, we can use this formula now to get our b value because we know what a is. Remember, a was 3. So we can now actually use that. We can now say that, okay, 3 times 3 plus b is equal to 7. Alright, so that means that 9 plus b is equal to 7. So b is going to be 7 minus 9, so negative 2. Alright, and there we have our b value. Perfect. Now the last step would be to find our c value, because in this formula we have 3 variables. Alright, so we need to find all 3. We found a first, then we used a to find b, and now we're going to use a and b to find c. Now the last formula that you need to remember is that a plus b plus c is equal to term 1. Alright, so that's not too bad. A plus b plus c is equal to term 1. Remember that we found our a value in the first step. Our a value is 3. Plus our b value in this next step was negative 2. Plus c is equal to term 1 of our number pattern, right? Term 1 is 6. Okay. 3 plus negative 2 is the same as 3 minus 2, right? You don't have to write that down as a separate step. You can just work that out straight away. And 3 minus 2, we all know, I'm sure, is 1. So I actually have 1 plus c over here is equal to 6. So c is going to be 6 minus 1, which is 5. So our c value is 5. What does that mean? This number pattern has a general formula, a general term, an nth term. Yes, there will be a recording on YouTube. Absolutely, I'm going to post this on YouTube. Okay, so now we want to put our a value in front of n squared. So we're going to say 3n squared. Then we have our plus bn. Remember, b is negative 2 now, so I'm just going to write it as minus 2n. And then plus c, our c value was 5. There we go. That is the general formula, the nth term, the general term of our quadratic number pattern. Right, and that is basically what you need to know for quadratic patterns. They are going to give you questions in matric where they combine quadratic and linear patterns, where they combine quadratic with geometric patterns, which is the new one, which is the one that you guys haven't done yet. All right, but I'm going to post lots of videos. Guys, you will be doing sequences and series for 3 weeks, right? That is the prescribed time according to the Department of Education. They prescribe that the school spends 3 weeks on sequences and series. Yes, my YouTube link is in my bio. So they prescribe 3 weeks for this section. I'm going to post at least 3 videos per week on sequences and series as you are going through the topic. I might post more. All right, there are lots of little finicky bits and pieces to sequences and series, but it's actually quite a nice section all in all. It's a nice way of getting marks. And I will try and go live at the end of the section again so that we can revise everything in the section. But for today, actually, that is all that we are going to do, because that is basically the revision of what you did in grade 11. Guys, my email is also in my bio, so if you have any specific questions that you want to ask me, if there's a question or homework, for example, that you're struggling with or that you don't understand the answer to, you can take a picture of it and just email it to me, and I will work out an explanation. I might even make a little TikTok video on it. But what I am also going to do is I'm going to record all of my lessons that I'm going to do in class. I teach at a coastal school, so my school only starts next week. But from next week, Wednesday, when I do my first lesson, I'm going to record all of my lessons and post on the YouTube page, YouTube channel every day. So if you want just some extra work, some extra examples, an extra explanation maybe, you can go watch my YouTube videos. I'm going to go through the section from start to finish on there. All right, thank you guys for being here. It's been real. Sorry for the shaky hand. I'm going to try and work on a different setup so that it's a bit more stable in future. But thank you so much, guys. See you next time. Thanks, Voo Voo. See you soon. Bye-bye.